version for AB tutoring, where learning is as easy as ABT. Now in today's session, we'll be going through algebra and more specific factorization. Now what is factorization? Now to me, it's a way of simplifying an algebraic expression, but I found a nice textbook definition for you guys. It reads, the determination of a set or divisors of given integers, prime factors, polynomials, so polynomial factorization, which when multiplied together give the original numbers or polynomials. Now I got this definition from Wolfram Math World. Now we'll be looking at four main types of factorization. These are factorization by common factors, by grouping. We'll be looking at the difference of squares, and we'll be looking at quadratic factorization. Now what we aim to do, we'll define all four factorization, the types, as well as we work a few examples just to ensure that you get a good understanding of what factorization looks like. Now starting off with factorization by greatest common factor or highest common factor or greatest common denominator or greatest common divisor, right? Now this sounds like primary school maths. Yes, I'm going to bore you with it. But what is factorization by greatest common factor? It is simply using the largest integer, whether negative or positive, that divides into the expression with leaving a remainder 0. Or no fractions, right? And this, of course, is just my definition specific to factorization, of course. Now, just for a refresher or a reminder, let's look at highest common factor or greatest common factors, right? If we have three numbers, 18, 30, and 54, what would be the greatest or the highest number that can divide into all three numbers without leaving a remainder? The simple answer, 6, and that would be the greatest common factor. Now we're going to look to apply this logic to the factorization, simple factorization or factorization with the greatest common factor. Now let's look at some simple examples for factorization. All right, starting off with our first example, right? 6x plus 6y. So what is our greatest common factor? So this one is easy, right? The greatest common factor here is 6. And what we would do, we're going to take out the 6. Let's use another color. We'll draw our brackets. And essentially what we do, we divide each term, each algebraic term, by the term that we put outside of the bracket. So in this case, it's 6. So 6x divided by 6 is x plus 6y divided by 6 is y. And easily, our answer becomes 6x plus y in bracket. And that's it for our first example. Now moving to our second example. 9p squared minus 3p. What are our greatest common factors? So we have a factor in 9 and 3, which is 3. That's the greatest common factor. It can go into both 9 and 3 without leaving a remainder. And we have p squared and p. And our common factor there would be p. Can go into p and can go into p squared. So what we'll put outside of the bracket? 3p. Now we'll divide each algebraic term by what we have outside the bracket again. So it's 9p squared divided by 3p. So this is 3p minus 3p, yes, I know I'm wasting your time a little bit, divided by 3p. 1. So our final answer is 3p, and in open brackets, 3p minus 1, close brackets. Now our third example, we have 18x cubed y squared minus 6x squared y squared plus 3x y to the fifth. Now, simple, just a longer way of doing the others, or a longer one for the others, right? But this is what they'll consider a difficult question, but it's easy, right? So again, we're going to look across all three algebraic terms and find the common factors. So let's start with the numbers, right? So we have 18, 6, and 3. So what is the highest common factor? Right away, I see where our highest common factor is 3. So let's write that for outside the bracket. Let's move to the x terms. So we have x cubed, x squared, and x. What is our highest common factor? Again, x. And looking at our y terms, we have y squared, and y to the 5th. Our highest common factor for y is y squared. Now, we're going to divide each algebraic term by what we put outside the bracket. So the first one, let's just do it easy. 18 divided by 3, 6. X cubed divided by x, x squared. Y squared divided by y squared is 1, so we move on. Minus 6 divided by 3, 2. X squared divided by x, x. And y squared divided by y squared, again that's 1. Plus 3 divided by 3, 1. X divided by x, 1. And y to the 5th divided by y squared, y cubed. Now, if we're having a little issue with dividing the powers or working with the powers, we have another video, Law of Indices. Feel free to browse that video to get a better understanding. It's good stuff as well. All right, now let's go into factorization by grouping. With this one, what we do, we're going to group the terms, right? So simply put, we will take the algebraic expressions, we're going to put them in pairs, and then we're actually going to use the greatest common factor to finish the factorization. So let's jump into an example, as simple as ABT. All right, so here's our first example. We have AX plus AY plus BX plus BY. So what we're going to do, we're going to group them in pairs, right? So let's just draw a line here. So we're going to split them. Now we're going to use our greatest common factor method, and we're going to factorize each side. So what is common between AX and AY? A. And again, we're going to divide each algebraic term, again, by what we have outside the bracket. So that gives us x plus y. Plus, what's common between bx and by? Obvious, b. And again, dividing each algebraic term, we end up with x plus y. Now notice, both brackets have x plus y. Now when you're doing common grouping factorization, this will always be the case. If you don't get it, it's wrong, right? So common grouping, this will always be the case. Now, we're going to factorize again. What's common between this term and this term? X plus y in the bracket. So now we're going to put x plus y outside the bracket, so by itself. And what we have in our new bracket, we're going to divide this term by x plus y, so that will cancel x plus y, leaving a. Divide this term by x plus y, leaving b. And our final answer is x plus y, a plus b. And that's it for factorization by common grouping. Now, let's look at our second example. xp plus yp minus x cubed minus y cubed. Now again, we're going to pair them. So let's split it right there. So what is common between xp and yp? P, obviously, right? So p outside the bracket, and we end up with x plus y in the bracket. Now this one is slightly more, a little more tricky, but still straightforward, right? We have minus x cubed minus y cubed. What's common between both of them? Q, but more importantly, minus q. So minus q outside the bracket. So minus xq divided by minus q, the minus signs will cancel, right? A minus divided by a minus, or a negative divided by a negative, gives you a positive. So you're left with positive x. And same here, a negative yq divided by negative q. Again, this will give you a positive. So this is a plus y. Again, what's common between these two pairs, or these two algebraic terms? X plus y, x plus y. So we bring that outside. And in our brackets, p times x plus y divided by x plus y will give you p. Minus q times x plus y divided by x plus y will give you minus q. And our answer is simply x plus y, p minus q. Now to our third example. X squared plus 3x minus 4x minus 12. Now, you'll see why I give you this example in the next few topics, right? You know, there's method to my madness. So, same principle again. That line wasn't perfect. So, we're going to split or pair them off. What's common between x squared and 3x? It's x. And in the bracket, we have x plus 3. And on the other side, what's common between minus 4 and minus 12? Minus 4, that's our highest common factor. And in the bracket, x plus 3. Again, we have x plus 3 common here. So it's x plus 3. On the other side, x minus 4. So our final answer, x plus 3, x minus 4. Now, let's jump to the difference of two squares. Now, honestly, I'm not going to spend a lot of time here. It's a very, very, very easy topic, right? It's literally what the name says, the difference of two squares. So, let's put it in general form first, right? General form is a squared minus b squared, right? So, our algebraic term, we have two, a squared and b squared. The first thing that we notice, they're two perfect squares, right? Because they're squared numbers or squared terms, yes? And we're subtracting both of them. So that's the difference of two squares. Now, the easy way to solve this, we draw 4 brackets. We write A and B in both with opposite signs in each. So our answer ends up being A plus B times A minus B, right? Or A minus B, then A plus B, right? Doesn't matter which one you put first, you know, multiplication is commutative, so it's fine. So let's work a few more examples. So the first example I have here is x squared minus 16. Now x squared is a perfect square and 16 is a perfect square. We know the root of 16 is 4, right? So again, all we're going to do, draw 4 brackets. We'll find the square root of x. We'll find the square root of x squared, x. We'll find the square root of 16, 4. And then we have different signs, plus, minus, or minus plus, doesn't matter. And that's our answer for the difference of squares for this first question. Let's look at our second question here. 8x cubed minus 2x. Now on the face of it, doesn't look like a difference of square, right? Because you've said, but Layne, 8 is not a perfect squared, nor is x cubed, nor is 2, nor is x. And I take your point. So the first thing we have to do, because sometimes you have combinations in terms of factorization. So the first thing we actually have to do is use, you know, highest common factor. So what's the highest common factor here between 8x cubed and 2x? And the answer is simply 2x. Now, 2 into 8, 4, and 8 cubed divided by x, x squared, minus, you know, 2x divided by 2x is 1. Now look what's in our bracket. 4 is a perfect square. Square root of 4 is 2. X squared is a perfect square. The square root of x squared is x. And 1 is a perfect square, right? The square root of 1 is 1. So we are going to expand this because this is the difference of two squares. So we'll keep our 2x out there. I'm going to use some square brackets. And again, it's simple. The square root of 4x squared is 2x. The square root of 1 is 1, and then plus and minus. And it's as simple as that, right? That would be our answer. 2x, square brackets, 2x plus 1, 2x minus 1, close square brackets. Now we have another combination for difference of two squares, right? X squared minus y squared minus 9x plus 9y. So the first one is obvious, right? It's a difference of two squares. So we're going to do the same thing here. Open bracket. Square root of x squared, you know the drill, x, x. Square root of y squared, y, y, plus, minus. Now we're going to look at this side. Minus 9x plus 9y. So if I say minus 9, open bracket, minus 9, so minus 9x divided by minus 9 is going to give me x. Positive 9y divided by negative 9, so we have a positive being divided by a negative, that's going to always give me a negative y. Now, between this term and this term, is there anything common? Yes. X minus y. So we pull that out, x minus y, and then what are we left with, right? In the bracket we have, if we divide this side by x minus y, we're left with x plus y. This side divided by x minus y, we're left with minus 9. And our answer here is x minus y, then on this side, x plus y minus 9. So finally, we're at quadratic expressions, right? Now, I'm factorizing quadratic expressions. Now, the general form for a quadratic expression is ax squared plus bx plus c. Now, we know that a would be considered the coefficient of x squared, b the coefficient of x, and c the constant term. Now, don't be fooled by this word coefficient, right? It's simply just a fancy word for, the number in front of. So a is a number in front of x squared, b is a number in front of x, and c is not a coefficient, it's just a constant. So we're fine with that. Now, in quadratic factorization, what we aim to do is to simplify so that we can use factorization by common grouping. Now, how do we do that? Right? We contemplate a times c giving us a product and b giving us a sum. Now, the best way to do this is to work an example. And I'll start with the general form and then we'll jump into a question. Now we're here. Let's look at the general form again. Ax squared plus bx plus c. Again, what we're looking for, a times c is our product and b is our sum. And we're looking to split the b term, the bx, into, let's say, a px plus a qx, right? Now, what is the criteria we need to satisfy? To split b, the two numbers must add to give us b, but when you multiply them, you get a times c. And that's the criteria. So now let's start with our first example. X squared plus 7x plus 12. Now remember the general form for the algebraic expression, right? Ax squared plus bx plus c. A, the coefficient of x squared is 1. B, the coefficient of x is 7. And c, our constant, is 12. Remember what we need to contemplate, right? A times c, which is our product, is equal to 1 times 12, so 12. B, which is our sum, is 7. Two numbers, when we add them, we get 7, and when we multiply, we get 12. So it's easy, right? 3 times 4, 12. 3 plus 4, 12. So positive 3, positive 4. Now we're going to split 7 into plus 3 and plus 4. Right, so let's split 7 into plus 3 and plus 4. So x squared plus 3x plus 4x plus 12. Now, this looks familiar, right? We kind of looked at it in factorizing by common grouping. Now, all we need to do, we pair them. And the rest you know how to do, right? Common factor, x here, x plus 3, common between these two, plus 4, x plus 3, x plus 3, x plus 3, x plus 4. And that's it. Our answer, x plus 3, x plus 4. Now let's look at our second example. X squared minus x minus 12. So again, what's our general form? Ax squared plus bx plus c. So a is 1, b is minus 1, c is minus 12. Again, what do we need to consider? A times c is our product, which is equal to 1 times minus 12, which is negative 12. And b, which is our sum, is minus 1. Again, two numbers, when we add them, we get negative 1. And when we multiply, we get negative 12. Now, the clue here is that we have a negative number. So we know it must be a negative and a positive number that we're going to split. We're going to use to split the x squared. Now, two numbers when we multiply, we get negative is negative 4 and positive 3. So minus 4 plus 3 is minus 1, and minus 4 times a positive 3 is negative 12. So that's what we're going to use to split the negative x. All right, let's split the x. So it's x squared minus 4x plus 3x minus 12. Again, I like using my red marker. So we're going to pair them. Common factor here, x. In bracket, x minus 4. Common factor here, 3. In bracket, x minus 4. X minus 4, x minus 4. Okay, you know what? I'm being a bit unkind. Let me write it a little better. X minus 4. And in bracket, oh, I left off the plus sign. In bracket, x plus 3. And there we go, our answer, x minus 4, x plus 3. All right, our next example. 2x squared minus 13x minus 70. Again, what is our general form? Ax squared plus bx plus c. A, number in front of x squared, 2. B, number in front of x, minus 13. And c, our constant, minus 70. Again, A times C is our product, which is equal to 2 times negative 70, which is minus 140. And B is our sum, is minus 13. So again, think about it. Two numbers, when we add them, we get negative 13, and when we multiply, it's negative 40. Again, the clue again, it must be a negative and a positive, right? Because we have negative 40. Now, what two numbers, when we add them, one negative, one positive, we end up with negative 13, and we'll multiply, we get negative 40. It's straightforward, right? It's negative 20 and plus 7. So we're going to split the numbers, 13 as negative 20 plus 7. All right, So let's split this now. So we have 2x squared minus 20x plus 7x minus 70. Splitting down the middle again. Common factors, 2x. So we're left with x minus 10. On this side is plus 7. X minus 10. We have x minus 10, x minus 10. So x minus 10, 2x plus 7. And there you go. Our final answer, x minus 10, 2x plus 7. And that's it for quadratic factorization. Alright guys, that concludes our episode on factorization. I hope you had as much fun as I did. See you on the next episode.